So, okay, good evening. So, we will continue with chapter 5. The remaining slides that we haven't completed that day. So, currently we are studying about the multi actuator circuit. Okay, so multi actuator circuit means the circuit pneumatic circuit with multiple actuators. So, meaning ada more than two, two or more, two or three cylinders. So for your syllabus, maximum three cylinder. So minimum two cylinder for multi actuator circuit. Okay. So sequential, I think we have covered this. On Wednesday, I have mentioned that there are three methods uh, to design. Okay, the first method we call it as a classical method. So number one and number two, classical. So just number two, you use a idle roller lever switch or valve in order to eliminate signal overlap. So we will study later. Okay, then we have a cascading method. So cascading method, I have given you at puzzle assignment. So for this week, we will learn about cascading method, and next week I will give another video for step counter method. So chapter 5 we will cover for 2 weeks, and please pay attention for all this classical method, cascading method, and step counter method, because every year for pneumatic and hydraulics there will be a design question from either one of it. So normally will be cascading or step counter. So classical, it will be available always. Okay, even the normal design we call it as a classical. So number 5 and number 6, so it's not discussed in the syllabus. Okay, so I just go through um, the classical method. So I think I already teach you. So I just want to emphasize again certain important things for you to remember. So in classical method, circuit design is done by using the general knowledge of pneumatic, following the sequence to intuitively in general. Okay, so the step involved, first you write down the sequence. So you draw the motion diagram. Okay, so motion diagram. Then you start to draw the cylinder and the control valve, and you need to complete the circuit intuitively. So meaning carefully. So classical method, we don't really have strict SOP that you need to follow. So it can be a bit flexible, but you need to make sure that you cover all the cylinders and also control valve involved. So any kena careful lah, because we don't have a strict SOP untuk follow. So student can make mistakes. So especially kalau lukis valve, so the arrow is not right. So maybe you don't have a input or compressed air and also exhaust. Lupa another lukis. So all that thing you need to be careful. Okay, so example 5.1. So this is a simple two cylinder case. Okay, feeding and also, so it's more on the packaging side. So you have a one cylinder. So how you want to solve using classical way? So you write the statement of the problem. So make sure inside your statement you have all the required cylinder and also the sensor numbers. So letak terus. Okay, so A means so jangan waktu lukis dalam exam you tak boleh boldkan letter. So make sure you write, let cylinder A be the first cylinder for pushing. Okay, and cylinder B is for feeding. You have a pushing cylinder. So there's a workpiece here. So this is cylinder A. So you draw in a positional layout. So kalau lukis macam ni, you nampak. So nampak. So okay. So this is for pushing. So this is for feeding. Okay. So apa yang you tulis dekat statement ni, So make sure you relate with this picture. Okay, then the second step, draw the positional layout. And then you draw, ya ini semua tulis pun tak apa. So untuk step 3, so you need to represent the control task using notational form. Yang paling penting adalah sequence. So sequence of the operation. Okay, sequence of the operation. So A plus, B plus, A minus, B minus. So example lah. So this information is very important to determine how you want your circuit to function. Lepas dah dapat sequence, so you number 4, you draw the displacement step diagram. So ini adalah displacement step diagram. So you only have step. So kalau you tak tahu macam mana nak lukis displacement step diagram, go and look back in chapter 4. Okay, so I pun ada bagi few tutorial questions dalam Google Classroom. So start to do from now. Start to find the answers. So soalan-soalan yang penting kita akan discuss. So soalan lain tu you can take your own time to find from the lecture note or from the internet. Okay, so this is your displacement step diagram. So dalam step diagram, so no information of time. So that's one more. So displacement time diagram. Yang ni ada information time T1, T2. So let's say this is 0. So this is 5 second. This is 10 second. So dia ada lah information dia. Okay, so depending on the time length, so the distance of the graph will be longer or shorter. So yang ni pun boleh tengok macam mana nak lukis displacement time diagram, rujuk balik chapter 4. So it's in chapter 4. Okay, then chapter 6. So you analyze. So here you need to determine what are the input signals and what are the output signals. So output signals, forward motion of cylinder A is A plus, return is A minus. So yang ni kita tahu. Input signal you need to find out. Okay, for cylinder A, setiap cylinder selalunya ada dua sensor. Okay, one is the ohm sensor, one more is the extended sensor. Untuk ohm sensor selalunya kita letak, if A, cylinder A, kita letak A kecil 0. So it indicate that is the limit switch A0. Extended, kita panggil as A1. So cylinder B sama lah. So if you have cylinder C, so it will be C kecil 0 and C kecil 1. So you need to know the differences. Okay, why you need to, we don't encourage you to use a capital A, because you will get confused with this cylinder name. Okay, so that's why. Okay, then yang ni adalah, so you're connecting the input signal with the output signal. So kalau ada A plus meaning the cylinder A extend, it will on the sensor A1. Maksudnya the extended cylinder A extended limit switch, yang ni akan on. So dia dah on, so it automatically start, cylinder B will start to extend. So kalau ada A1 on, so automatically B plus akan start to gerak. So it will be sequence. So one after one. So all the sensor input is actually related to the motion of the cylinder. So yang ni kita boleh letak dalam motion diagram. So if you find it like a bit confusing, yang ni try to learn how to draw the motion diagram. Okay, so it will start from B0, meaning cylinder B retracted. So B0 adalah on. So baru cylinder A akan extend. So extend. So extend, it will activate A1. So A1 will activate B plus. So it will be until it finishes back with B0. So this is for one complete cycle. Okay, so selepas tu baru boleh lukis. So you already find all the information, you already know the sequence. So kita dah tahu sensor apa yang ada. So input and also output, everything kita dah tahu. Then we start with step 7, which is the drawing of the power circuit. Okay, so don't do the mistake like your seniors. Dia tak buat step-step ke depan, terus start with step 7. So you'll get confused in between. Okay, so you'll get confused. So boleh tengok. So first you draw the power circuit. Power circuit meaning your cylinder and also your valve that controlling the cylinder. Itu adalah power circuit. So lukis yang ni dulu. So you can see here. So you have a cylinder. This is cylinder A. Cylinder A. So this is your limit switch. Okay, so A is 0. A kecil 0. So that means kalau cylinder balik ke tempat asal, yang ni akan on, yang ni akan off. Sebab yang ni hanya akan detect if the cylinder extended fully. Kalau dia extended fully, A1 akan on, A0 akan off. Okay, so it's like that. So in this case, you have 2 cylinders. So kena lukis dua set. Okay, so this is for your set. Name it accordingly. So jangan tulis A, dekat sini pun A. So this is A means this is B. So if you have another cylinder, is C. So yang ni pun lain. Okay, so draw this first. Then you can complete based on your motion diagram. Okay, so kalau cylinder A nak extend, so you need to give input at this side. Yang port 14 ni, kena bagi input. So this side is connected to extension of your cylinder. So yang ni retraction of your cylinder A, yang ni extension of cylinder B, and this is retraction of cylinder B. So kita dah tahu dah lokasi ke mana kita nak lukis. So go back to your motion diagram tadi. So if you want cylinder A to start extend, one of the condition adalah B0 kena on. Okay, so B0 dekat sini. So meaning macam sequence tadi, so cylinder B dah retract balik, so baru on B0. So this is one main condition. Sebab itu letak dekat sini. So you have gambar dinding, so meaning cylinder B0 is on. Kemudian baru you connect dengan push button. So yang ni on, so you press the push button, it will switch valve. So compressor akan masuk, yang ni pun on, so it will go through to this port. So pergi ke this port, yang ni akan ubah and your cylinder A akan extend. Cylinder A dah extend fully, so A1 akan on. So A1 akan on, so sequence dia A plus, B plus, A plus, B plus, A minus, B minus. Sequence dia. So lukis berdasarkan. So position of these sensors must be according to your sequence. So yang ni dah extend. So A1. Yeah. So A1 ada dekat sini. So kalau your sequence is A plus, B plus, A plus, A minus, B plus, B minus. So dia dah sampai dekat sini. So A1 boleh letak dekat sini. So it will retract. So macam tu lah. So it depends on your your sequence. So here it extend, A1 on. So A1 on, dia akan hantar signal dekat sini. So cylinder B akan extend. So cylinder B extend. So B1 akan on. So B1 akan on. So B1 letak dekat sini. So it will send signal for your cylinder A to retract. Dia dah retract, A0 on, A1 off. So A0 letak dekat sini. So letak dekat sini. So what will happen? Your cylinder B akan retract. So that is how you design using classical method. So classical method, the SOP is flexible. So you boleh letak dekat the suitable place. So if 2 cylinder case ataupun 3 cylinder case, so maybe this method is look not so complicated. But if you have in industry, you have too many sensors, ada banyak cylinders, ada banyak sensors, then classical way is a bit troublesome lah. Yes, especially when you want to do troubleshooting, maintenance. So dia akan ada masalah. So if less complicated circuit, you can design using classical way. So if a more complicated one, maybe you can opt for cascading method or step counter method. So yang itu kita akan belajar in coming weeks. Okay, so this analysis saya boleh baca lah. Okay, so I'm not really going through. Okay, so this is A plus operation. So you press the push button, ada gambar tangan dekat sini. So this is on. So it will send signal here and your cylinder will start to extend. So that is A plus operation. So after A plus, so cylinder A dah extend, cylinder A1 on. So A1 will activate this and your cylinder B will start to extend. So that is B plus operation. So cylinder B dah extend, dia akan on B1. So B1 ada kat sini. So this is A minus operation. So cylinder A retract, kena dekat A0. So then this A0 akan on. It will send signal for cylinder B to retract. So that is the overall operation. So this is generally what classical designing a pneumatic circuit using classical way. So itu adalah classical way. So step counter, kita akan belajar some cases in your tutorial. So nanti saya akan cover, akan try to teach lah apa yang perlu. Okay, so classical method, another disadvantage. So another disadvantage, kekurangan dia, so is it can cause signal overlap. Kalau signal overlap, hari itu saya ada bincang sikit, ada bagi sedikit input what is signal overlap. So dekat sini kita akan belajar lah. So what is actually signal overlap? So overlap maksudnya bertindih. Okay, so signal yang bertindih. So that is the translation of signal overlap. So signal bertindih meaning, so you receive 2 or 3 signals at the same time. Itu yang kita panggil as signal overlap. So kita baca sikit. So we read first. Okay, signal overlap can occur when simultaneously 2 active signal appear on both set and reset pilot port of final control valve. So macam ni. So ini adalah control valve. Here B0 pun aktif, A0 pun aktif. So it will send compressor here, compressor here. Then what will happen? So this valve will receive 2 active signal. Itu yang dipanggil dekat sini, 2 active signal. So port 14 pun dapat signal, port 12 pun dapat signal. So what will happen? So this is due to the required sequencing of cylinder. At the start, the both signal A0 and B0 appear at the same time. Dia berlaku same time. Okay, so both side receive the same instruction at the same time. So what will happen? So ini adalah kompresor macam saya bagi tahu itu. So the valve position will not change, meaning it cannot decide. Kenapa cannot decide? Because the compressed air from this side and compressed air from this side having the same pressure. So same pressure. So cuba bayangkan water pressure. So same pressure but at the opposite direction. What will happen? So dia akan kena dekat one point and it will just stop there. It won't go anywhere. So similarly lah. So both sides have the same pressure. So this valve will not result in any changes. Itu yang dibagi tahu dekat sini. Okay. So how you can eliminate signal? Okay, signal elimination adalah proses untuk overcome the signal overlap. So, okay. So signal overlap tadi adalah satu masalah. Yang ni adalah solusi dia. Okay, so this is the solution. So this is the problem. Okay, so there are 3 methods. So 3 methods for you to eliminate one signal out of 2. Okay, so first you can use idle return lever limit switch. So boleh gunakan yang apa, nanti saya tunjuklah ada slide selepas ni. So I will show how it can eliminate. So it will only allow, so this type of limit switch will only allow input from one direction. So kalau macam silinder dia pergi depan dengan belakang kan. So maybe depan dia detect, dia ke belakang tu dia tak akan detect. So it has some mechanical mechanism to filter that. So that is one type. Then we can use a cascading method, and also we have step counter method. Okay, so cascading method and step counter method are specially designed for signal elimination. So itu adalah satu kaedah yang dicipta untuk mengalang signal bertindih. So or make a signal selection macam tu. Okay, so we will see few example. Okay, so this is a clamping and riveting. So riveting application. Dia satu cylinder tu, dia hold the workpiece, one more will revert. Okay, clamping one adalah cylinder A, and riveting adalah cylinder B. So reverting cylinder. So daripada description we know the sequence. So cylinder A extend, B extend, B retract, A retract. So meaning A plus, B plus, B minus, A minus. Okay, A plus, B plus, B minus, A minus. Okay, boleh tengok dekat sini. So starting, ini adalah sensor. This is for first cylinder. So 1S1 and 1S2. Boleh tengok. Dua-dua pun I. Okay, so dua-dua pun satu. Okay, 0 or 1. So 1 maksudnya dia on. So 1S1 and 1S2 dia attach dengan cylinder A. So dua-dua pun I. Dua-dua pun I. So dekat sini pun dua-dua pun I. So if both I, so meaning is signal overlap. So ada few situation where signal overlap occurs. Okay, boleh tengok. So this is cylinder 1A1. So nama dia 1A1. And this is 2A1. So boleh tengok. At this case, dua-dua side dapat input. So you press this. So dua-dua side akan dapat input. So your cylinder will be undecided where to go. So dia ada masalah ni. So ini adalah masalah yang pertama. So the first place dia ada signal overlap. Kita tengok dekat sini pun dua-dua pun I. Dua-dua pun I, so it has the same problem. Okay, so both side receive input. Okay, so classical method tadi kita tengok. So classical method also can be used. So there are two types of classical method. Macam tadi saya bagi tahu. So two types of classical method. So tadi yang contoh yang kita tengok adalah classical method one. So there's another method, classical method with idle roller lever limit switch. Okay. So that is to eliminate the signal overlap. Okay, so this is a normal roller lever limit switch. Yang ini adalah idle return roller limit switch. Dia ada betul macam tangan. So it give a mechanical signal which sends both direction. So yang ni roller, the normal roller lever limit switch. So it will detect from both direction. Dia akan detect from both direction. Tapi yang ni, so it only detect in one direction. So meaning if we receive signal from the opposite direction, dia tak akan ambil lah. So it will not take. So it only will take in the direction you set. The other direction it won't take. So it can help with signal elimination. So kalau ada false signal, dia akan cancel. Automatically will cancel. So you can see here, so idle return roller valve. So an idle return roller consists of, okay, so dalam ni adalah 3/2 direction control valve. Then you have a idle return roller mechanism. Okay, so dekat bawah ni ada switch. So you have a switch here inside. So depends on the movement of this. Yang ni dia macam lock dekat sini. So it will go up or down. So kalau dia turun ke bawah, so it will tekan yang ni, dia akan on. Okay, akan on. But you see here, so it has a mechanism. So kita akan tengok the next slide how it can illuminate. So dia kena dekat surface. Yang ni dia cuma akan gerak ke depan ke belakang. Dia takkan tekan benda ni. So it will not press. It will only move front and back. But it has a certain direction that it can detect. Macam contoh dekat sini. So you can see. So your cylinder extends. Dia ada dekat sini. Roller valve ada dekat sini. So your cylinder extend. Okay, please hold on. Okay, so you can see. So boleh tengok. So ada A, B, C and D. So this is a sequence. Ikut arrow ni. Okay, so first the cylinder extend. So ini adalah idle return roller valve. Okay, so dia langgar dekat sini. So yang ni dia akan push. So it will push and on the switch. So valve actuated. So valve actuated meaning valve on. Okay, so lepas tu cylinder extend lagi, dia dah lepas. Dia dah lepas roller ni. So it will go back to the original position. So dia akan pergi ke original position, dia akan macam jadi bengkok. So the cylinder will extend. So yang dalam case ni, valve is released. So meaning dia tak on. So valve release, dia macam tak ada lock lah. Then what will happen? Dia balik. So dia return balik, what will happen? So dia cuma langgar dekat sini. Walaupun dia langgar, so it will not be actuated. Because switch dekat bawah ni dia tak tekan. Because there are no bending involved. Okay, so because it only can detect in one direction. Lepas tu dia dah balik ke tempat asal. So yang ni pun is not actuated. So you can see the mechanical movement of the idle return roller valve is actually can eliminate, only select macam dekat sini, it only select from left to right. Right to left, it eliminate, it is not taking because of the mechanical flexibility. So itu adalah kelebihan idle return roller valve. Okay, so you can see here. So this thing is designed using Automation Studio, but you can design similarly in your fluid sim. So boleh tengok. So you can change it to idle return roller valve. So meaning, even though there's a signal overlap at part 1 and part 3, but because you're using different how to say the different type of roller valve, idle return, so dia boleh eliminate the signal. So dia boleh eliminate. Yang ni you cuba design balik lah. So try design back in your fluid sim and see how's the output. Okay, the use of roller lever valve with idle return to eliminate signal overlapping has the following disadvantage. So earlier, That's the advantage. The advantage is for you to um, eliminate the signal overlap. Tapi dia ada some disadvantage juga. Okay, so what are the disadvantage? The end position cannot be sensed accurately. So if you see here, so walaupun your cylinder is fully extended, tapi dia tak detect sangat. So normal roller valve dia akan ada uh, dia akan kena, then dia akan stop and it will be detected. But here in this case tengok fully retracted pun dia tak detect, valve is not actuated. So it has some limitation dekat sini. That's why it's saying the end position cannot be sensed accurately. So we have some disadvantage because ideal return roller valve, your focus will be to eliminate the signal, uh, but at the expense of the end position cannot be sensed accurately. So you disadvantage dekat sini lah. Okay, so function may be impaired as a result of contamination. So maybe there can be problem lah kalau ada contamination because it's a mechanical device. So maybe ada contamination, so maybe berlaku apa karat ke ataupun kat atas tu ada rubber, so you have a rubber layer on top at the roller. So maybe you have additional dirts collected there and it detect as a contact point. Uh, so dia tak boleh impact maksudnya dia rosak. So since it's a mechanical sensor, so there can be contamination, inaccuracy because of contamination. Dia tak tepat because ada kekotoran dalam tu, dalam sensor. Okay, so that's one thing. So fast control system are not possible. So this is another disadvantage where because you tak boleh gerak terlalu cepat. Because terlalu cepat, maybe it will on the idle sensor. So you need to extend like slowly, and you need to be careful, so that it will not trigger false alarm. So what will happen because you are like being careful? So you cannot do things at a fast speed. So macam ada speed trap lah waktu you pandu kereta. So suddenly you noticing there's a speed trap, ada EES. So you automatically slow down because you want to be careful. So similar. Because the ideal return roller valve, the main advantage will be to eliminate signal overlap at the expenses of all this. Dia akan jadi disadvantage. Okay. Cascading method and step counter method, we will cover after you finish the video. Okay, so video will be, I already gave an add puzzle, saya dah bagi untuk cascading. So next week Wednesday we will discuss on the cascading method. So kita akan cover cascading dulu, then only we will go for step counter. So, okay, so I think that's all for today. So ada soalan tak? So any questions?
Tak ada, sir.
Okay. So kalau tak ada, so we will dismiss early. So 3:37. So I will upload this video, recording video for your reference. Okay, so thank you. So we will meet next week Wednesday.
Thank you, sir.